Hello everyone and welcome to this video in which we are going to learn about geometric series. Okay, so a couple of things we have to recall first, or really just one thing, and that is, what is a sequence? So we recall that a sequence is simply an ordered list of numbers. You can also recall from the video on arithmetic series that a series is the sum of the terms in a sequence. Okay, so a sequence is an ordered list of numbers, and a series just takes the sum of those numbers in that list. Okay, but in this video, of course, we want to know about a geometric series. So what is a geometric series? A geometric series, you might be able to guess, is, well, it's a series, so it's the sum of the terms in a sequence. But what type of sequence? Well, of course, a geometric sequence. Okay, so a geometric series is the sum of the terms in a geometric sequence. And just to completely recall everything we need to know, a geometric sequence, in a geometric sequence we have a common ratio. Or another way of saying is that the ratio between any two consecutive terms is constant. Okay, so that's the geometric series. Let's look at a quick example. Okay, let's look at this example. Here we have a geometric sequence. So not a series, just a sequence. Okay. How do we know it's a geometric sequence? Well, there's a common ratio. R is equal to 2 because 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, etc. It's always multiplied by 2. So that's how we know it's geometric. And how many terms do we have? Well, this would be T1, T2, T3, T4, T5, T6, and T7. So it's a geometric sequence with 7 terms. So what would be the series? The series is now the sum of the 7 terms. So the series would be this: 1 plus 2 plus 4 plus 8, etc. Okay. How do we denote a series? We denote a series by capital S subscript n. Okay, so you can think of the S as S for sum, because we're always summing in a series, and this is n subscript, refers to the number of terms in the series. Okay, so if this is how we denote it with Sn, so in this case we've got 7 terms, so we denote this as S7. Okay, so that's a specific example, but now let's look at a more general example. Okay, in the general example, let's say we have a sequence like this. Okay, and it can go up to, let's include Tn minus 1 and then stop at Tn. Okay, so we're assuming, of course, this is a geometric sequence. Okay, if it's geometric sequence, we're going to recall the general formula. What is the general formula for the nth term? This is something you need to know. So it's a multiplied by r to the n minus 1. So I'm just going to make a note here. This you need to know. And where a is the first term and r is the common ratio, right? So if I were to take this sequence here, this general form of the sequence, I could rewrite it as such. So T1 would just be A, T2 would be A multiplied by R, T3 would be A multiplied by R squared, T4 would be A multiplied by R cubed, etc. This would be AR to the n minus 1 minus 1, which is n minus 2, and this would be AR n minus 1. Okay, so what would be the series? This is just the sequence, right? Because we're not adding here. So the geometric series would be, well, the sum of these terms, right? And we denote it as Sn, so it would be A plus AR plus AR squared plus AR cubed all the way to AR n minus 1, the nth term. Okay, so this is what it looks like, but this is not very practical. So the question is always, can we find a formula? Can we find a formula for Sn? And the answer to that is yes. And not only yes, it is also something you need to know. So it's something you can be examined on. Right? So yes, and you need to know. Okay, so let me show you the proof for how we determine this formula. Okay, so imagine you're being asked this question in the exam. Determine a formula for the sum of n terms of a geometric series. So if you ask this question or something, or it's phrased in a slightly different way in the exam, this is what I'm going to show you now is how you should answer. So what I'm going to do is, I'm just going to rewrite this equation here. Okay, and so we can get some nice clarity. So Sn is equal to the sum of the first n terms. Okay, so this we know, this is given. N minus 1. In fact, I'm going to add in this term here as well and then put in my dots. Okay, now in mathematics, whenever we prove something, there's often nice cool tricks we can do to get to the result that we're trying to prove, if you recall as well from the video on arithmetic series. Okay, so what I'm going to do is, I'm going to call this equation 1, equation 2, and you'll see later on why I'm going to do this. I'm going to take everything from equation 1 and I'm going to multiply it by r. So I'm going to multiply both sides by r. So on the left hand side I'm going to have r multiplied by Sn, right? And then I'm going to multiply everything on the right hand side by r as well. So a multiplied by r, I'm going to get ar. AR multiplied by r will give me AR squared, right? AR squared multiplied by r will give me AR cubed, right? AR cubed will give me, multiplied by r will give me AR to the 4, all the way up to AR n minus 1 to the n minus 1 multiplied by r will give me AR to the n. Okay, so why did I do this? Well, here's the cool trick I was telling you about. What I'm going to do next is this. I'm going to take equation 1 and I'm going to subtract equation 2. Okay, so on the left hand side, I'm going to get Sn minus R Sn. Okay, then on the right hand side, I'm going to write out all the terms. So everything first from equation 1. And then I'm going to subtract all the terms from equation 2. So first term AR, second term AR squared, AR cubed. Oh, my apologies. There should not be a plus. I'm subtracting. Right, AR4 all the way up to, what's the last term in the second equation? That's AR to the n. I'm going to write out this equation as well, or that term as well, and the last one, AR to the n. So what's going to happen here? On the left hand side, I'm going to take out a common factor of Sn, and then it leaves me with 1 minus R. On the right hand side, and here's where the cool trick comes into play. Here I have AR. Here I've got minus AR. So these cancel. Here I've got AR squared. Here I've got minus AR squared. So these cancel. Here I've got AR cubed. Here I've got minus AR cubed. So these cancel. So you can see what's going to happen here. Everything's going to cancel all the way up to this term here. AR to the n minus 1 cancels out with that minus AR to the n minus 1. So what am I left with? All I'm left with is A and this last term minus AR to the n. Okay. Now remember what I want to do is, I want a formula for Sn. So I need to isolate Sn. So I'm going to write the left hand side again like this. And then take out the common factor of A on the right hand side. Okay. And then to get Sn alone, I'm going to divide both sides by this factor here. 1 minus R. So I'm going to get Sn is equal to A 1 minus R to the n divided by 1 minus R. And this right here is your formula for the sum of n terms in a geometric series. Okay, before I close off this lesson, there's another useful formula which I wanted to show you, and it's similar, in fact exactly the same as in the video with arithmetic series. Another useful formula which can be useful in problem solving. So what do we know? We know this, right? This is the sum. So this is very general now. I'm using T's again, T's and subscripts. Okay, and this is equal to, again, the sum, but this time we're going to stop at Tn minus 1. Right? So in fact, let me write out here, let me write it out like that. Because when I take Sn minus 1, what's going to happen? I'm going to have a T1 term, and I'm going to subtract a T1 term. So this is the same like equation 1, equation 2, taking equation 1 minus equation 2, right? So I've got T1 minus a T1, those are going to cancel. T2 term minus a T2 term, those are going to cancel all the way and I'm going to be left with just Tn. So this right here is another useful formula that might come in handy in problem solving questions to do with geometric series. Okay, so Tn is equal to Sn minus 1, and that brings me to the end of this video.